Hello, in this video we'll be discussing the concept of statistical process control. So what exactly is statistical process control? Well, it's a graphical process used to help identify variation and possible causes of such variation in logically related activities. What this means is that given a process where we might be able to observe a pattern, we can predict future behavior of said pattern, and this helps us identify abnormal variation so that it can be eliminated from said process. The key thing to point out is that we're able to predict when that future behavior will happen, but not exactly why it happens. But predicting the when is just as useful as we can usually deduce what the problem is from that alone. When making a statistical control chart, the first thing to do is determine units for whatever event we are choosing to measure, as the chart itself will be graphed as units against time. Then, depending on the process, it's recommended to have at least 20 to 25 samples to accurately portray the process. After graphing that, we then graph our line for the average to clearly identify the mean value over time of the data. Once we have the means, we determine our data point outside of those limits can usually be seen as a special cause and not a statistical control, signifying that something needs to be corrected in the process. Even behavior that might be non-random, such as shifts, trends, and cycles, may be significant enough to be considered a special cause. As you can see, I have my little trusty cowboy engineer here ready to wrangle in the special causes and attempt to keep this process under statistical control. Utilizing statistical process control, we have to ensure we are using the right control chart for the variable we want to measure. For variables that we can measure to significant decimal places, we use what is called a variable data control chart, the most common of which is the X bar and R chart, and a variation of such called the I and MR chart. However, as an engineer concerned with manufacturing, an attribute data control chart will typically be used. This is used for variables that we're able to count rather than finally measure. It can help with something like measuring the amount of defects that come out of a manufacturing line. P and MP charts are the most common, and C and U is a variation of such. As for applications in the engineering discipline, statistical process control is nearly limitless. Most manufacturing processes want their variation to be as close to a normal distribution as possible, and this makes them easy to correct as it means any outlier on an SPC chart can be seen as a disturbance and gives a clear goal of what should be fixed. However, statistical process control isn't necessarily 100% effective on its own. It's still merely a tool to measure variation and requires a person using it to properly interpret the results. For example, in a manufacturing environment, there's usually 5 variables that may be a result of special cause in any process, and those are manpower, methods, machines, materials, measurement, and environment. A statistical process control by itself cannot tell you which one is the cause. However, when correctly utilized, a manufacturing process can see improvements in both quality and cost, as using an attribute data control chart like mentioned earlier, we can count defects and accurately predict when they happen in the manufacturing process. Thank you for watching my video.